Today we're going to graph absolute value functions. And so we're going to start by just graphing y equals absolute value of x. And as long as you need to graph something on a two-dimensional window, a valid strategy for graphing it is going to be to make a table of values, plot some points, and connect the dots. Okay, so I'm going to go through, and for these x values that I've written down, I'm going to take the absolute value of them, and then I'm going to plot that as the y value. Okay, so absolute value of -3 is 3. Absolute value of 1 is 1. And there we go. Okay, and then I'm going to go over here to the graph and start kind of, marking off 3 each direction. In the y direction, I don't need to go any higher than 3, so 1, 2, 3. Okay, so -3, 3. -2, 2. -1, 1. 0, 0. 1, 1, 2, 2, 3, 3. Okay, so we've got a bunch of points, and then we're going to connect the dots. And we're also going to assume that the graph continues on the same pattern outside of these dots. And so we see that same V shape that we saw in Algebra 2, maybe in pre-calc, we took that last year. We've seen it before. And then what I'm going to show you is that eventually this point here, that corner point, that sharp turn, that's going to happen where we end up taking the absolute value of 0. But more on that in a couple minutes. Okay, if we were to just look at, say, the right side of this graph, it didn't work. It wouldn't let me erase the left side. But if you just ignore the left side, we could say that if we were just looking at this portion of the graph, that looks like the line y equals x. So I could say that it's basically x if x is positive, or maybe equal to 0. And then over here, if we look at this portion of the graph to the left of the y-axis, this looks like the line y equals -x. And that's the same definition of absolute value that I took a couple of times ago when we were just talking about absolute value equations. Okay, so now you all do the same thing, plot points, connect the dots, see what comes back. Okay, so I've plotted the points. I'm going to connect the dots now. And I've got a graph. This is another one with a sharp corner. Okay, over here, the sharp corner is right here at the point 2, 0, okay, which is that one. It's where I took the absolute value of 0. If we look back to the previous example, we'll see that over here, where the sharp corner was, where the vertex is, that's where we took the absolute value of 0. That will be true in general. That's going to be where the behavior switches from decreasing to increasing, or whatever, is where we're taking the absolute value of 0. Okay? Because basically it's here also. Where is the behavior changing? So in general, our steps for graphing these things are going to be, first we're going to plot the vertex. I'll show you how to do that. We're going to plot some other point. And then we're going to use the symmetry of the graph to basically reflect that second point you get a third point, and then we'll connect dots. Okay, as for actually finding the vertex, what we're going to do is we're going to take whatever's inside the absolute value, this x plus 1 in this case, and we're going to set it equal to 0. Okay, so we're going to solve for the vertex. To find the x coordinate, I'm going to say x plus 1 equals 0, and then I'm going to solve for x by subtracting 1 from both sides. I've got x equals -1. Then I want to know what the y coordinate that goes with -1 is. So y of -1 is 2 times the absolute value of -1 plus 1 plus 3. This is 2 times the absolute value of 0, which it should be because that's how I picked that x, is it was what was going to make the absolute value take the absolute value of 0. And so that equals 3. Okay, so our vertex is the point -1, 3. So there's -1, here's 1, 2, 3. Okay, there we've got ourselves a vertex. Then I'm going to just choose some other point. Okay, since I haven't done it yet, I'm going to choose x equals 0. I'm always going to choose x equals 0 if it's not where the vertex is. Okay, and then y of 0 is going to equal 2 times the absolute value of 1 is 2 plus 3 is 5. Okay, so 0, 5. And I go through and I point that, or I plot that point. And so if I had to go to the right one from the vertex to get to that point, I could go to the left by 1 and have the same y value. Okay, because of the symmetry that these absolute value graphs have. They have this symmetry about their vertex. So then I'm going to come through, I'm going to connect the dots, and I'll be happy. All right, so moving on to the next one, I'm going to have one with maybe a couple more moves. Yeah, we've got y equals 3 times the absolute value of 3x plus 3, then add 1. Okay, so I'm going to start by solving for the vertex. So I'm going to set this thing inside the absolute value equals 0. Okay, then I need to find the y coordinate that corresponds to x equals -1. So y of -1 is equal to 3 times the absolute value of 0, then add 1, which is 1. All right, so I am going to plot the vertex, which is going to be -1, 1. And then I'm going to plot some other point. Okay, I recommend choosing x equals 0, but you can choose whatever you'd like. Okay, I've got x equals 0, so I need the y coordinate that corresponds to x equals 0. So y of 0 is equal to 3 times the absolute value of 0 plus 3 plus 1 equals 9, and 1 is 10. Okay, so I've got 0, 10, so I'll just mark this as 10, plot that point. Okay, if I've got 0, 10, and the vertex was at x equals -1, at x equals -2, I'll also have y equals 10. And then I do that. That's not the best graph ever, but, you know, I'm doing this one. All right, so that one, it caused it to be significantly narrower. Okay, so now I want you to try y equals the absolute value of 3x minus 6 on your own. I'm going to freeze the screen, and I'm also going to pause the video here in about 10 seconds. Then you can, you know, after it comes back with all the answers, you can check your work against mine. All right, so there you go. So I found the vertex to happen at, what is it, 2, 0, and then I just plugged in 0 to find my other point. and I reflected it across the vertex. Okay, so I said if the vertex happens over here where x equals 2, and I plotted 0, 6, which was 2 units to the left, I need to go 2 units to the right to get the other point. And so that's where I went over to where x equals 4, y is also going to be 6. I plotted that, I connected the dots. I know what the shape of an absolute value graph is. It's a V or an upside down V, and then I go from there. Okay, next we're going to talk about the graph of y equals the negative absolute value of x. And so what I'm going to do is I'm going to go back to the first example we did, and I'm just going to extend this table. And I'm going to make a new column. I'm going to plot this one, I think, in, say, green. And I'm going to do this, make this negative absolute value of x. Okay, so if this column is the positive absolute value of x, I can make the negative absolute value of x by just making everything negative. Okay, which is like taking all of these y coordinates on the red graph and making them negative. So negative 1, negative 2, negative 3, negative 4. Okay, so 0, negative 0 is still 0. Okay, and negative 1, negative 1, negative 2, negative 2, negative 3, negative 3. Okay, so negative absolute value x is kind of like an upside down V. So over here, if you were asked to sketch the graph of y equals negative absolute value x, well, you would know, you'd be able to do that real quick. You could say it's just an upside down V. Okay. We can do that. Okay, this next one looks like it's got pretty much all the moving parts on it. And so I'm going to start with a vertex. I'm going to take x minus 3 and I'm going to set it to 0 to find the x value of the vertex. I'm going to add 3 to both sides. And I've got the x value of the vertex. Then I'm going to find the y value of the vertex. So it's negative 2 times the absolute value of 0 plus 2. And then that's going to be 2. Okay. So I've got a vertex that's 3, 2. Excuse me, got a little distracted there. Okay, so our other point is going to be where x equals 0. All right, so y of 0 is going to be negative 2 times the absolute value of negative 3 plus 2. So this is negative 6 plus 2 is negative 4. So I'm going to plot the vertex. I'm going to plot the other point, which is 0, negative 4. And then I'm going to reflect. Okay, if I, over here, negative 4, went over 3 units to this thing, I'm going to go over 3 more units, approximately. Say that's the other point. And let's clear out that stuff. And I'll connect the dots. Okay, so we're seeing that the negative makes it open down. The 2 makes it maybe a little narrower. The 3 on the inside is affecting the x coordinate of the vertex, and the plus 2 is somehow affecting the y coordinate of the vertex. Okay, another type of problem that we can look at is maybe an inequality with these. Okay, now what I would probably say is more likely is that we'll look at this and we'll look at the region enclosed by the graph of this thing in the x-axis, not necessarily all the area down below it. So I'm over here. I'm going to find the vertex. Looks like I'm plotting in red. That's x equals 0. Whatever's on the inside of the absolute value, you set it equal to 0. And then you find out what y of 0 is. Y of 0 is negative 2 times 0 plus 3. Okay, so the vertex is 0, 3. So maybe I'll set that here. That's 3. Okay, then the other point. Okay, well, x equals 0, I already did that one, so I'll just do x equals 1. So y of 1 is going to be negative 2 times the absolute value of 1. That'll be negative 2 plus 3 equals 1. So my other point is 1, 1. All right, so 1, 1. Okay, now if 1, 1 is on the graph, then that means negative 1, 1 will also be on the graph because of the symmetry of these absolute value graphs. And so I'm over here, I'm connecting the dots, and I've got that. Okay, so if they're saying y is less than, what you're going to want to do is you're going to want to shade where y is less, just like we did in the previous couple of units. Okay, that's where y is less, so that's really all of this. All right, the last type of question that we can ask you with this is, maybe ask you to produce a graph of a function and ask you to find the area of the region enclosed by the graph of the function and the x-axis, or maybe the perimeter of a similar region. So now I'm going to just kind of zoom in over here on f of x equals the negative absolute value of x plus 6. Okay, well, I'm going to need to find the vertex of this thing. Okay, the x-coordinate of the vertex is wherever we're taking the absolute value of 0. So you take the thing on the inside and you set it equal to 0. Okay, x equals 0. And then you're looking for f of 0. Okay, that'll be the y-coordinate. That'll be negative absolute value of 0 plus 6, which is 6. So I'll say that maybe that's 6. I know it opens down because of the negative absolute value, so I'm going to just try to figure out what the zeros are. Okay, and I'm interested in where the x-intercepts of the zeros are, so I'm going to set y equal to 0. So I need f of x equals 0. So negative absolute value of x plus 6 equals 0. That means negative absolute value of x equals negative 6, or absolute value of x equals 6. And from a couple of times ago, we know how to solve that equation. Say that's true either when x is 6 or when x is negative 6. Okay, so I kind of just plot those points and I connect the dots. Okay, so now we've got this region. I shaded it. We're going to find the area and perimeter of this region. It is, at the end of the day, just a triangle, so I think it's something that we can do. Let's see. Okay. There we go. Okay, so for the area, I know that area of a triangle is equal to 1/2 times the base times the height. That is something that you're expected to know in this class. Right? So the length of the base, what is the length of the base if I was to just, label it like that? What is the length of the base? 12, yes? Okay, base is equal to 12. Height, okay, I'll label height in purple. Okay, here the y-axis is looking like a pretty convenient altitude for this triangle. Okay, so it looks like the height goes from the x-axis up to 6, so that's 6. H equals 6. So then the area is going to equal 1/2 times the base times the height. So 72 divided by 2 would be 36. Okay, now if they asked us to find the perimeter, well, really what we would need is we would need this distance over here that I'm now labeling in brown colors. Okay, so we got to figure out what this is. I'll call it C. Okay, so the perimeter is going to equal 12 plus C plus C. Okay, so we're going to find it by, all right, we're going to, I don't know, just take one of these triangles and use the Pythagorean Theorem. So this is half of it. That's 6. That's 6. If we have 6 and 6, what's the third side? You were in that class last year. I know you were. Yes, in the trigonometry class. If you have 6, 6. Do we not know? Okay, now convince me you do not know what the third side is going to be. So what do? We use the Pythagorean Theorem. Okay, we know if this is C and we've got 6 and 6, this is 6 squared plus 6 squared equals C squared. Okay, so that's 36 plus 36 equals C squared. That's C squared equals 72. You could just say C is the square root of 72, but y'all have got those really nice scientific calculators that will simplify radicals. So when you put it in there, you're going to find that that's the square root of 36 times the square root of 2, or 6 root 2. Okay. You don't remember a 45, 45, 90 triangle? Okay, yeah, that's so it's x, x, x root 2. Okay, 6, 6, 6 root 2. All right, so this is, now the perimeter is going to be equal to 12 plus 6 root 2 plus 6 root 2, which is 12 plus, I guess, 12 root 2. Any issues there?